Welcome, my friend. You have jumped into the middle of a three-part saga where we are unpacking the definition of a network. In a previous nugget, we defined what the network was, and we explored the subnet mask and how the subnet mask helps these computers understand what their network is, and when the computer becomes smart to really understand what it can reach on its own network versus when it has to use the default gateway to get off of its network. Now, I'm not running through these bullets in order. That would be boring. So let's jump over here to the public and private side of this list, because I've kind of been going with the analogy of networks like a house. Like if you come to my neighborhood, you would come to the Chara's house. And in the Chara's house is the Chara's rules. And that's how this land of 172.30.100 exists. This is the network environment. This router introduced a network boundary to where we can create custom rules and in our own design of the devices on 172.30.100. And I'll expand on a lot of what you can do with networks that are separate from each other later on. For now, we're just defining the boundaries. We're defining the houses instead of living in this giant commune. Now, just like the houses in my neighborhood, there's an outside and an inside, right? I don't know if you've got one of these in your neighborhood, but I do. It's an HOA. And what they are there to do, it stands for Homeowners Association, is keep the neighborhood looking good, right? You can't just have somebody come and paint their house, fluorescent pink, because people are like, oh man, like I'm trying to sell my house and my neighbor just went fluorescent pink on me. Who's gonna want to buy my house and live next to this fluorescent pink house? So the HOA says, okay, here is your color palette and template, and you can only paint your house, these specific colors. And anytime, I have actually been standing on the ladder, brushing up the trim of my house and had a car stop. And they're like, what are you doing? Are you approved to do that? I'm like, I'm just trying to paint the trim, right? So there's rules for how I manage the outside of my house. But imagine that same thing. If I'm inside of my house painting the wall, this guy busts down the door. He's like, what are you doing painting that a fluorescent pink? I'm like, I like pink. I want it in my house. He's not going to do that because it's my house. And inside of my house are my rules. I've got fluorescent pink walls and nobody's going to tell me I can't have them, right? So it's the same thing with this public and private world. In the world of IP addressing, there are actually three separate ranges defined as private addresses. Rather than write them all on the whiteboard, let me just drag over Google where we can see these address range. I just typed in private IP addresses on the Google field, and I see these ranges listed right here. Now, first off, can I underline this? RFC 1918 name. RFC stands for Request for Comments. When somebody creates a standard, like let's say I want to make an industry standard toaster that works on a network, right? I would create an RFC standard to say all toasters that are manufactured in the world must adhere to these standards in order to be considered an industry standard toaster, right? And if you don't abide by these standards, then you've got a proprietary toaster there, my friend. Nobody's going to want your toaster because it's proprietary and it won't work on their network, right? So you would come up with a request for comments, and there are thousands of RFC articles out there, all in different stages. Cisco rarely makes you memorize an RFC number. This would be the exception. If there's one RFC number that you remember off the top of your head, it should be RFC 1918. Because this RFC, if you were to Google RFC 1918, I encourage you to do that, you'll actually see the white paper and this long explanation that defines why these addresses were determined to be and how to use these addresses as private IP addresses. That means if you are using addresses from any of these ranges, and chances are that you are inside of your home networks or inside of your business networks, if you're using addresses inside of these ranges, they are considered private and they will not be able to route on the internet. I had to choose my words very carefully when I said that because there is a misnomer. You will often hear people say, oh, well, private IP addresses are non-routable. No, they are not. Wait, hang on. No, they are not non-routable. Yes, they do route. Private addresses route all day. Like if I brought up an internet, or not an internet connection, but a connection on this router to an office, let's say this is in Arizona and this is an office in Texas, they will route all day right over that link and be able to communicate to all the devices that are sitting over there. No, reason people call them non-routable is because every internet service provider If they claim to have the badge of internet service provider, I am a provider of internet service to customers, they should put, notice I said the word should, is they should put a firewall rule in place that prevents these addresses from getting out on the internet. Why? Because they're private. People are supposed to be able to use them without regulation. It's kind of like, radio frequencies, right? There's certain ranges of frequency that you can use without regulation. That's why we can have cordless phones in our house. We can set up our own wireless networks. Well, it's the same way with private IP addresses, is I can use these things anywhere I want without regulation, without registering them or anything like that. Now, when I said ISPs should block them, there was actually a case out in somewhere in the world. I don't remember the name. It's not the United States, but there was another area of the world where there was an ISP that forgot to do this. They actually forgot to block private addresses. And when you start learning more about the internet, you just find out it's a network of networks, and ISPs are connected to other ISPs and other ISPs, and it's this big mush of all these networks connected together, right? And all these other ISPs assumed that this ISP would be blocking them, so they didn't put the filters up on them, and it actually caused a countrywide internet outage wherever this was, because these private addresses got out and caused all kinds of problems in the network world of today. So when you hear private addresses and you hear people say it's not routable, that's not true. It's not true at all. The internet service providers just put up firewall rules that keep those ranges of addresses, and let me bring them back up again, those ranges of addresses, these guys right here, from getting out on the internet. So what does this mean? Notice, first off, number of addresses. This, in enterprise businesses, large companies, is usually the addresses that they're used. Number of addresses, 16 million addresses that they can use. Now, again, using different subnet masks, they break that up into smaller little network boundaries, going back to one of the previous network nuggets where I define the networks. But chances are in your house, you probably are using one of these, because most of the time when you buy a commoditized D-Link or TrendNet or Linksys or whatever router you buy from Best Buy or Fry's Electronics, it just automatically hands out addresses from 192.168.0 or 192.168.1 as the default. So and I was just talking with my friend yesterday. I said, okay, how many business networks did you deploy using 192.168.0.0 before you're like, this is like a mark of shame on my record? And it's kind of true. Like I would say when you get into the businesses more and more and more, you start realizing people using 192.168, it's kind of like it's like an unsaid thing. It's like, if somebody walks out on the football field wearing like thick rimmed glasses, you're like, what are you doing? It's like you're a nerd on the football field. So it's the same kind of like, this is how nerds feel cool, right? We look at 192.168 and we're like, well, that's the home range. If you use that in a business network, then you're kind of like, it's like snicker. It's not that it doesn't work. It's just, anyway, what am I talking about? Let's get back over to the public and private world. Because I haven't answered the most important question of all, as we've been talking about this public and private space. Okay, I just said private addresses don't route on the internet. But then I made this statement. I said, well, okay, most homes in the world will be using 192.168, so these are private addresses. Most large businesses will be using these addresses. This example right here, 172.30.100. I look right here, I go 172. Yep, that's right there in that range of private addresses. So the question is, how on earth, if private addresses don't work on the internet, how does this computer surf the internet? It's got a private address, right? Well, that's where the savior of the internet as we know it, and now the biggest prohibitor of progress as we know it, NAT, comes onto the scene. NAT stands for Network Address Translation, and it is a router function. What NAT allows you to do is translate these addresses from private into public. And more importantly, and probably the key attribute of NAT that we're looking for, is the ability to overload a public IP addresses. So you can have the internet service provider give your router one public address. Let's just say it's 1.2.3.4, right? And using NAT, you can actually share that, technically speaking, for up to thousands of hosts inside of the network. Now, that's technically speaking. In actuality, that would break down and you'd need a few more public addresses if you had thousands and thousands of hosts. But technically, you could share this. So I could have all of these hundreds or thousands of computers inside of my network that as they go out of this router, they assume the identity of this one public address. Like I said, savior of the internet as we know it, because we have long since exceeded the number of IP addresses, at least in the TCP/IP version 4 space, that exist. So the only thing that we could do is start sharing it. And using that, we could share one of these addresses for thousands of internal devices. So, wow, that's awesome, right? Well, it is, but they've come out with TCP/IP version 6. And when I say they've come out, it sounds like a late breaking thing. But I remember when I first got into teaching, and this was back in 1996, I was telling people TCP/IP version 6, it's going to change the world. It's probably going to happen by 2002. And this is when I'm teaching Microsoft IIS classes. I know nothing of network technology for the most part. And everyone's like 2002, mark your calendars, end of the world, all that kind of stuff. So version 6 gives us I would say virtually infinite number of addresses, but there's been a real challenge to get people to move to it because NAT has extended the life of version 4 far too long, and actually now is a prohibitor of innovation. So, still to this day, I would say in the world, a guesstimated 90 to 95% of all the networks in the world are running TCP/IP version 4, and it's still going to be a long time before the world converts over to IP version 6. So that's why we need this public and private concept. See, when we move into IP version 6, we don't have the need. You can still do it, but we don't have the need for private addresses anymore because we can now have everything directly, publicly addressed with a real Anyway, I'm getting way ahead of myself. The whole goal right now is to talk about public and private. Inside of our networks, we use private addresses. When they hit the router, they use network address translation to translate into a public internet valid addresses. We can do virtually anything that we want. As a matter of fact, can I blow your mind for a second? We can use public addresses inside of our house. We can use public addresses that we don't even own. If I wanted to say, you know what, I'm feeling kind of wacky today. Let's make this the land of 178.30.100.0. And I bring this up and I go, well, actually, the 138, that's outside of the private address ranges that exist. So now I'm using public addresses. Will it work? Well, actually, yes, it would. If I'm using NAT, I can translate these guys just as well to this 1.2.3.4, and it'll work. What's the problem? Well, if you ever have a website out here or a device you want to access out in the world that has the address, let's just say 178.30.100.52, let's just say, and then this guy tries to access it, it's going to fail because it's going to think, oh, well, that's on my network. I don't need to go to the router to reach that device. It must be somewhere out here, and it's technically not, so it's going to fail. So you would actually be preventing yourself from reaching that group of addresses, whatever addresses you made up on the inside network. But my point is it's totally possible. Man, I love this stuff. I could talk about the core of networking all day and just keep unpacking all these little fun pieces the whole way through, but I've got to stop. We've got now a definition of what networking is all about. We know what private addressing and public addressing is all about. Join me in the next nugget to really learn how we put these puzzle pieces together to create network communication. I hope this has been informative for you, and I'd like to thank you for viewing.